Good afternoon, Algebra 2 Trig Honors class. So, we'd like to talk about some of the sample questions for the Chapter 5 test for the upcoming Friday. So, here's one of the questions. So, what we got is 625, k to the power of 12 to the power of 1.25. So, one of the formula that we know, the radical form to the exponential form with the rational exponent. So, anytime they see the structure like a to the power of m over n, so this one can be always converted to the radical form. It's nth root of a to the power of n. So for the base right here, so first thing that you want to do, so you probably want to convert that decimals to a fractions. So this one is considered 1 and 1/4, so then that'll be 5 over 4. And then from here, we want to distribute the power, so 625 to the power of 5/4. And then we do have k to the power of 12 times 5/4. And then for that 12 times 5/4, this one can cross cancel. So we got 3 times 15. So which is what? 15. And then 625 to the power of 5/4. So this one is written as 4 root of 625 to the power of 5. So once you break it apart, so 4 root of 625 is consists with 5 times 5 times 5 times 5, which is 5. So 5 to the 5th power. So that means it's just 625 times 5. So 5 times 5, 25. 2 times 5, 10. Plus 2, 12. 6 times 5, 30. Plus 1. So 3,125. So this one is considered 3,125 times k to the power of 15. And that would be the final form. And now, and more complicated structure with the multivariable x, y, sometimes z with the rational exponent. So again, the way to deal with this, we try to use that the order of operation, PEMDAS. So you started with the parentheses right here, especially the denominator, things that looks kind of complicated. So the top part, we just want to bring it down, rewrite it. And then the denominator, we do have x times, well, x to the power of 2/3 times x to the power of 5/3. So that considered product to sum. So this one would be considered 2/3 plus 5/3. And then for the y, so similar. So it's -2 plus 5/4. Again, so same base, multiplying. So we need to combine the exponent. And then everything else, just rewrite it. So now, for the rest of this, so once we combine this, so this one is x to the power of 7 over 3. And then y to the power, -2 plus 5/4. So -2 is considered -a over 4 plus 5/4. So then that'll be -3/4. And then don't forget about that, the base, top and the bottom, we got y and x. So now from here, we can apply that the quotient to difference. So the one with the same base, so subtract the power, so 4/3 minus 7 over 3. And then y to the power, well, this one is just like 1. So 1, which is considered 4 over 4, minus 3/4. Minus -3/4, because that's subtractions. And then the whole quantity to the power of 2. So what we got here, so x to the power of -3 over 3, which is -1. And then this one, 4 plus 3, so 7 over 4. So y to the power of 7 over 4. And then quantity square. So again, the power outside the parentheses, we want to distribute. So once you distribute, so you do end up with x to the power of -2. And then y to the power of 7 over 2. Because once you multiplied it out, so it's a power times the power. And then again, negative exponent, we want to put it down to the bottom. So it's a reciprocal form. So it's y to the power of 7/2 all over x squared. And that's the final form. Again, for the denominator, make sure that you don't put in any fractional exponent. So there's no fractional exponent in the denominator. Okay, so now let's see what else that we have for the rest of this. Solving the radical equation. Sometimes this one can be written as 29 minus 2x, the whole quantity, which is what, to the 5th power, and then cube root of the whole quantity. So what I did here, I just rewrite it as a radical form, and then the rest of the constant, you just want to carry them over. But it's easier to do it with the exponential form. So instead of using that, the radical form, it's easier to deal with this with the exponential form. Okay, so one thing that you want to do is subtract 4 both sides. So what we got is 29 minus 2x quantity to the power of 5/3 And then 247 minus 4, then that'll be 243. And now for the exponent, in order to get rid of the exponent, so you want to multiply the power with the reciprocals of 5/3, which is 3/5. Again, both sides, multiply the power by 3/5. And then this one can cross cancel. And what we got is 29 minus 2x. So 243 to the power of 3/5. Okay, so let's see what that is. So this one is considered 5th root of 243 to the power of 3. So 5th root of 243, then that would be considered 3 to the power of 3. So then that would be what, 27? So 29 minus 27 equals 2x. So what I did, I just swapped those terms. So that means 2 equals 2x. And as you can see that, we just turned this one from the exponential form, the radical equation, to a linear equation. So that means x is 1. Because you want to divide it by 2 for each side. Again, anytime you want to check your work, you can always plug in a number back to the original equation. And then you just want to check that it's the same number on both sides. Okay, so now let's see what else we have for this. And number 4, graph and state the domain and the range. So anytime that you deal with the graph, we do have two different types of radical. One is the even root, like square root. And the other one is it's the cube root or the odd root. Okay? So the difference is that the value of h and k. So if that's an even root, so that means h comma k, it's always the vertex. If that's an odd root, h comma k, it's always considered the point of inflection. Okay, so that's something we talk about from the notes. So one thing that you want to do, you want to take out the greatest common factor. So on top of this one, the numerator, so obviously is what, 16. So take out 16, so we do have x minus 1 over 25. And then one thing we notice, square root of 16 over 25, that's 4 over 5. And then the radical, so make sure that you put in that x minus 1 under the radical. So compare and contrast, so we do have a equals 4/5. And then for h, we do have 1, and then k equals -1. So basically just started with the xy coordinate. So this one, h comma -1, so h comma -1, so that would be 1 over to the right, down 1. And then you want to find out more points, so set up the xy table. So put in that any number that can make this one as a perfect square number. So what we can do, so let's put in 2. So 2 minus 1, that's 1. So 1 times root 1, that's 1. 1 times 4/5, that's 4/5 minus 1. 4/5 minus 1, which is -1/5, -0.2. So 2 comma -0.2, so somewhere down here. And then also you can plug in more number, so you can get more positions of the graph. So the next one you probably want to put in, let's see, 10. Or maybe perhaps 5, so a little bit closer to the position. 5. Again, so once you plug in 5, so this one, 5 minus 1 is 4, perfect square number. So square root of 4, that's 2. So 4/5 times 2, then that'll be 8/5. 8/5 minus 1, which is 3/5. So 5 comma 0.6. So that's all the way up here. And then the rest of this, simply connect them. And then you want to state the domain, the range for this. So the domain for this one, so as you can see that the end point, the left end point, so starting at 1. So that means bracket at 1, and it goes all the way to infinity. And then for the range, this one pretty much that covers the minimum all the way to infinity. So the minimum value for y, which is what? -1. So at -1 all the way to infinity. And now for the cube root function, it's quite similar to the square root, but that one for the parent graph, it's always considered a snake, a sideways cubic curve. Okay, so we'll take a look at that. So again, anything that you can simplify inside the radical, you always want to do that first. So it looks like this one we can take out the greatest common factor, which is what? 8. So we do have cube root of 8 times the quantity of x plus 6. And then minus 3. And one thing that we know, cube root of 8, that's 2. So 2 cube root of x plus 6 minus 3. Again, compare and contrast. So the value of a is 2. So that means a vertical stretch with a scale factor of 2. And then h is negative 6. And then k, which is negative 3. Okay, so I need to get some space right here real quick. And then once you find out the point of inflections, so you can start it with plotting points. But the thing is that one point is not good enough. So we need to get more positions of the graph. Okay, so again, so set up that xy table here. We're going to use that later. So we do have the x-axis, y-axis. So negative 6, negative 3. So 1, 2, 3, 4, 5, 6. Down here, negative 3. And then for the xy table, so let's say that we want to put in something that's easier to evaluate. So let's say negative 5. Because negative 5 plus 6, that's 1. Cube root of 1, that's 1. 1 times 2, that's 2. 2 minus 3, negative 1. So negative 5, negative 1. And also you want to extend the x-axis a little bit further. And also try to get something that's close to the point of inflection. So let's say negative 7. So negative 7 plus 6, that's negative 1. Negative 1 times 2, negative 2. Oh, you know what? Cube root of negative 1, that's negative 1. And negative 1 times 2, negative 2. Minus 3, negative 5. As you can see that, it's always symmetrical, negative 5. And also you can find out something that's a little bit further away. So let's say that x equals 2. Because 2 plus 6, that's 8. Oh, you know what? That's actually the... Okay, let's use 2. So cube root of 8, that's 2. 2 times 2, that's 4. 4 minus 3, then that's 1. Okay, so 2, 1. Right up here. And then all you need to do is simply connect those dots. So what I mean by the reflections, the point of reflection, or the inflection. So this one, as you can see that for this region here, the curve is actually facing upward. And then up to the point of inflections, down here, the curve is actually facing all the way down to the bottom. And then state the domain, the range for the graph. So the domain for this one, since we do see that it's all real numbers, so that means for the domain, it's negative infinity to infinity. And then for the range, also the range, while the curve is actually increasing slowly, so also it's going to cover all the real number, negative infinity to positive infinity. Okay, so now let's see. And number 5, functions, operation, and compositions. So given that g of n, h of n, and you want to find out the quotients, g over h of n squared, and then the composite functions, so g of h of n over 2. So anytime that you see the function operation, you can always rewrite this one with the separation form. So this one, once you separate it, so it's g of n squared divided by h of n squared. And then find out g of n squared. So basically just plug in n squared for n. So we do have n squared, quantity, square. Plus 2. And then for h of n squared, quite similar. So that one is linear. So it's negative 4 times n. So instead of using n, we're using what? N squared. So we just want to change the variable with the new quantity. Okay, n squared. And then minus 5. And then this one here, we can simplify it a little bit. So n squared, quantity squared. So this one, that means n to the power 4 over 2, all over, minus 4n squared minus 5. And that would be the simplest form. And then for the composition function, so you want to start it off with the inner function first. And according to the inner function here, so that's h of n over 2. So let's find out h of n over 2. So for h of n, it's negative 4n minus 5. Again, so for the rest of the elements, so we just want to keep the exact same thing. But for that variable, so we just want to use that n over 2. And then from here, you want to simplify it a little bit. So negative 4 times n over 2, which is negative 2n minus 5. And now we want to put in negative 2n minus 5 into g of n. So negative 2n minus 5, quantity, square, plus 2. Again, instead of using that original variable, we're using the new expressions for that variable. And then the rest of this, you can always expand it. So by the time you expand it, you can just simply FOIL, multiply this binomial twice, or using that the binomial expansions. So that would be considered 4n squared minus positive 20n, and then plus 25, because negative times negative, that's positive. And let's see what else. Plus 2. So that means the final form is going to be written as 4n squared plus 20n plus 27. Alright, composition function. Okay, so now let's see the last type of problem. So finding the inverse of a function. So again, anytime that you want to find the inverse, always you want to rewrite the function in terms of x and y. So that's always the first thing you want to do. So 3 minus the quantity of x plus 2 to the power of 3 all over 2. And then the next step, so you want to swap the variable. So x equals 3 minus y plus 2, the whole quantity, to the power of 3 all over 2. And then here's the most difficult part. So after you rewrite it, after you switch the variable, so the next thing that you want to do, you want to solve for y in terms of x. So a lot of people might be confused a little bit here. How do we isolate that variable? Should we take the cube root first? Should we subtract the number, multiply the number? Well, here's the thing. Whatever the number that is not related to the base to the power, you always want to cancel out those numbers first. So first thing that you want to do, subtract 3 on both sides. So now, on the right hand side, what's left here? It's just negative y plus 2 quantity to the power of 3 over 2. And now the next thing you want to do, you want to multiply both sides by negative 2. Okay, because this one is dividing by 2, but there's a negative 1 here. Or you can say that, just multiply the reciprocals of negative 1/2. So multiply by negative 2 on both sides. Okay, so simply multiply negative 2 on both sides right here. Okay, again, change the color. So now you can see what I'm doing. Okay, so what happens if I need to multiply by anything else here? So negative 2 times the quantity of x minus 3. So there's no need to distribute. So the rest of this, so all you need to do, so this one got canceled. So we got y plus 2 quantity to the power of 3. And then what we got here, it's what? Negative 2x plus 6. Okay? If you try to distribute that, and then cube root both sides. So once you take cube root both sides, you do have cube root of negative 2x plus 6. And that equals what? Y plus 2. And then subtract 2 on both sides, so we do have cube root of negative 2x plus 6. And then minus 2. So then that'll be the inverse of f of x. So that'll be the final form. Okay, so check that, and thank you for watching the video today.